Hi Joshua. Can you do this problem in geometry?
Yes.
Yes, R sub A, R sub B, R sub C. You can start with their X radii opposite ABC respectively. Show the area of ABC is equal to S minus A times R sub A, which is equal to S minus B, R sub B, which is equal to S minus C, R sub C. And let it be 1 over R sub A plus 1 over R sub B, 1 over R sub C is equal to 1 R sub B, where R is the in radius of the triangle ABC.
Yes. So I have prepared the
Figure in
structures in GeoGebra there. So this is ABC. There.
Nakamute siya yung audio, so unmute my audio.
No, it's not muted. Okay. Let the wait, I will just review. Let the X center opposite C be JC. So therefore this X circle is the CX circle is circle JC. It's J sub C. So now let this circle J sub C be tangent to line AC at J. So therefore G sub C G is an altitude of AC G sub C, which is this polygon. Yes, this is true because the any tangent to a circle is perpendicular to the radius from the center to that point of tangency. So this is perpendicular. So therefore, it becomes the altitude. Okay, so now let similarly, if H is where circle J sub C touches line BC. So therefore, similarly, we have this altitude J sub C H, which is an altitude of J sub C B C. So we will need to use there. So now J sub C H is the altitude of J sub C B C. And then finally, if we have our point of tangency F, the there point of tangency F, then we show the J sub C to F that is perpendicular to AB. So therefore, that is an altitude of this polygon AB J sub C. Okay, so here we just show. We'll stop sharing for now. We showed, see, this is ABC. And arbitrarily let this be J sub C. Then therefore, we show that, oh wait, let me extended. There, trying my best.
Yes, the triangles. AG sub C, C, and triangle BC, J sub C.
So now we just showed that J sub C, J is the altitude of AC, J sub C, and J sub C, H is the altitude of another obtuse triangle, J sub C, CB, BC, J sub C. And then finally, we have this last triangle over here.
AB, J sub C.
Yes, so I will just point out here. This is F. Wait, I'll expand this. It's getting too crowded.
Yes, okay, below.
It is too wide. There. Okay, see the marvels of new technology. Anyway,
Yes.
so J sub CF is now the altitude of ABJ sub C.
Triangle BC, J sub C.
So the triangles, oh wait, the respective colors. The question is about the area of ABC. So what is the area of ABC in terms of these areas? It turns out this area may be something different. This area on our figure, which is this area, I mean, I'll just shade it. This area, which is ABC, corresponds to this area.
Yes.
So in essence, we can easily deduce that this line area minus the red area plus the red area minus the light blue area is equal to ABC.
So which
So now in terms of math, area of red triangle ACJ sub C plus area of BCJ sub C plus minus area of cyan triangle or light blue triangle ABJ sub C is equal to ABC. Okay, so now
you should you tell
Ah,
them
yes.
that let can use a different color if you want. Let the X center opposite C be J sub C. So just to complete your solution. There's a different color.
Wait. Okay. So now it seems like we'll be ending up with this. And yes, because since where's our figure? No, stop showing. It should be below. In our figure, obviously, this is our X circle, which is the CX circle or circle J sub C. J sub CH, J sub CF, and J sub CG are radii of the X circle. So those are X radii. And here it is listed down that let R sub A, R sub B, R sub C be the X-ray opposite A, B, and C. So these X radii J sub C is J sub CH, J sub C F and J sub C G are the X radii opposite C. So that is X radius C or R sub C is equal to J sub C H. Okay. So now A sub wait, where is it?
which is equal to R sub A, R sub B.
No,
No?
those are different radii, as I will show later.
Okay.
Okay, so now we already know the R sub C in this equation. So there must be R sub C somewhere here in these three terms. And yes, since this is the area of a triangle, I told you earlier that J sub C, G, and all of those X radii are the altitudes of their corresponding triangles, where J sub C G of the red triangle, J sub C F of the lime triangle, and J sub C H for the lime triangle, and J sub C F for the cyan triangle. So these sides AC, I will denote them as with the same. AC is equal to the small letter of the opposite vertex. I'm just using standard naming protocol. BC equals A, and then AB equals C. So one half area of a triangle is one half BH. So AC J sub C is equal to one half base is ACB, and then G sub anyway. They're all X, right, and they're all X radii, CX radii anyway. BC. No, I ran out of space. Anyway, one half. Sorry, here. One half AB. What's AB? AB is C or C. Okay, there. So now we can express this in terms of A, B, C, and R sub C. Okay, so next page. I can't copy paste. Sad. What is the equation again? It shows the AB. AC factoring. Actually, wait. There, okay. Integrated. So does this seem familiar? If yes, this is the same perimeter.
Nice.
Yes, okay, we have this one. Then I will just highlight. Okay. I won't explain it in full detail, all of the other ones. But anyway, I will show these ones. So show hide. This is JA. Uh, what happened? They keep showing up randomly. Okay. So this is the wait, what is this doing here? Okay, there. So this is the A center and circle. These are the points of tangency, and these are the x radii. So those are the altitudes of the polygons. These ones. Wait. Those polygons. And then now there was a missing something. Never it is in the way. Show again there. So these are the respective origins of. So as I was saying earlier, yes, the X radii are not the same indeed. Wait, what are we doing? There, these triangles and this triangle, those those three triangles. Yes. So those are the eventually we will just use the same argument anyway. So I want to elaborate it. Eventually we will find out that for the analogs of the AX circle, you actually all you have to do is change every C here with A, and then every C here with B, like every instance of C, or except this one
Yeah,
because that's the
similar.
sign.
Like
So anyway,
you can put similar.
just do it. RB times B. We will end up
Using
with
the
this.
similar argument.
Okay, so this is our result.
For letter A, yes. Nice.
More civilized way of doing things.
How about for B?
Dun dun dun. Okay, so this is check. Check. Where's the check? There. So now B. Okay, so B is it's not really simple, but it is much simpler now that we know our facts. Okay, so B was 1/2 RA, what R sub A So there's a harmonic relationship between the X radii and the in radius. This is the in radius. It's just the standard naming protocol if and someone doesn't know. So since we know that ABC is equal to S minus A RE. And so that's RE 1 over So now we just substitute. Also, I forgot to say there's a theorem means that the semi-perimeter times the radius is equal to the area of the triangle. I'm not proving that now. It is rather long. So anyway, the in radius is equal to S over ABC. So now you see what I'm going to do. I'm just going to substitute. Actually, there's a question mark. I needed to put it. Think there. So there over so just combine like terms. And then I will already distribute out the minus sign, the negative. Okay, so see LARPing. So A plus B plus C, what could that possibly be? That is the perimeter. And wait, what's 3S? 3S is S plus 2S, which is the perimeter. And then A plus B plus C is the perimeter. Oh, well, not P, big P. There. So apparently, this cancels.
Yeah, so people red here, also it's brown. And like this, and like that is perimeter, it does be this on the side.
Okay, so
Please go to us, but also
Hmm.
here, so they know. Like, this one.
can see.
Be super difference. Yes. Oh, those,
Two S.
like this.
Oh, script test moment. Lol.
Okay.
Okay, so check. That means this is a check two.
QED. What QED?
Wait. I mean, actually, I have to put QED here.
This QED. Oh, what's it?
Quad erat demonstratum, I think. I don't know if I pronounced it correctly. Which was to be proved. Yes, in Latin.
Yes.
Yes.
Okay.
So I guess that's it. Thanks for
Thanks for
watching.
watching.
I hope you learned something. Bye.